Okay, hello everybody, and welcome to this webinar. I hope that you can hear us and you can see the screen as well. Just react on the chat if it's okay, because you cannot react. Great, very nice. Today, the webinar topic is around the Data4PT Validator, which is the validator for NeTEx datasets, and in the future also for Siri datasets as well. We have as facilitators Peter Kvarnfors,
yes.
Sorry, who is our developer, our main developer, together, of course, with his team. And he will do the demonstration of the tool, but also present some other aspects of the tool that are of interest for you. Then we have our two experts from Data4PT experts team, Nick Knowles and Stefan De Kock. Hello, Nick. Hello. That they will show, they will present more details. We will show the agenda just afterwards. And I have also Manuel De Verdal, my colleague from ITxPT, and myself, that we will try to do the introduction. So from my side, I will just update about Data4PT for those that joined for the first time our webinars, and then Emmanuel will enter more into the details and explain why a validator from Data4PT, what is the added value that we try to achieve here. So very quickly, we can go to the next slide, please, Peter. So based on the agenda that we have planned for today, as I said, we will spend probably less than 10 minutes on the introduction part. Then we will have Peter doing a demonstration of our validator, which is called Greenlight. Then Nick Knowles will deep dive into the validation rules that are the main addition that we have in Data Validator. Stefan will show us some real-life examples of data sets, what are the errors that we might get, and how the validation rules that we introduce will support to monitor these errors and, of course, to correct them. And then we have one part, last part, dedicated to those that they want to customize the tool based on their needs, because this is also one of the main key capabilities of the tool that we want to develop and make available. And then we will have something like 5 to 10 minutes for Q&As. And you can write your question already on the chat. And then we will take it over later on. So just a very small overview of Data4PT for those that they joined for the first time. Data4PT is actually the CEF program support action. Is funded by CEF. DigiMove is the project officer for us, and the idea is to have this support action to accompany and facilitate member states and all the other relevant stakeholders in the implementation of multimodal travel information services delegated regulation. And Data4PT has two main communication channels. The one is the web interface, the website, sorry, where you will find the training material, you will find the tools, including the tool that we present today, the training material, including the PowerPoint and the recording of today's webinar. But we have also other ways where you can find useful information, and we have also the possibility to receive your request for support. This is also available on our website. And then we have the wiki page, where we have more technical information. We have also some questions and answers, FAQs that we received during these last 3 years that the project is running. And inside this wiki page, we also have information about the existing tools, as that was also the background work for the validator that we will present today. So as you will see, and as also Emmanuel will explain you, we have done research on what exists, and the idea of our validator is more or less to be the backbone of the validation of the future. So Emmanuel, the floor is yours.
Yes, thank you, Anastasia, and good afternoon, everyone. So I will just introduce in few words the reason why such data validators are so important. So first of all, the main goal through this type of tools is to take care about the high quality data, because right now, thanks to some EU regulation and MMTIS in particular, we start to get access to some quite large data sets. So in every member states, you are right now already collecting such a mobility data. But of course, one of the key challenge then is to make sure that the use of such data sets can be done and can be useful to feed any type of systems like a journey planner of other mobility solutions. And this deals with different types of data, and you're quite familiar with this information, of course. It's on one hand the static files, so basically what's around the NeTEx data exchange format, and the dynamic APIs, which are all around the Siri data exchange. And as just mentioned, Anastasia previously, you are already using some tools which have been either developed by your own or taken from different types of company to check some level of compliancy, level of consistency, level of quality of the data. And what we let's say discover or highlighted during this preliminary work around the collection of existing tools is that it's quite heterogeneous the way such a tool are developed and used. And sometimes we even had some scenario where we discover that outcomes of different tools can be different for a single data set. So one of the objectives through DATA4PT initiative is to, let's say, try to harmonize such tools to get a universal and reliable way of data validation. And that's what we already start to deliver quite already a few weeks ago,
months ago,
even months ago, through the first release of the DATA4PT validation tool, which is already available on DATA4PT website. So some of you already had the chance to use it, to test it, to report also some feedback about it, and thank you, by the way. That's very valuable, of course, to get your return on experience around it. And that's the quite famous Greenlight tool you can access, and Peter will make a demo in few minutes. If we just look a little bit more in detail, what is around the tool about this Greenlight software. So first of all, this is an open source tool, and this was a strong requirement and mandate from the European Commission, the frame of Data4PT, to deliver such a tool as an open source. So this means for you that you can adopt it, reuse it, and enrich it according to your need. That's also an extensible tool, quite flexible in sense you can configure it according to your local rules, and this is quite important because the tools is expected to fit really to each of your needs, each member states, each even cities or region. You can have some different rules to check the quality of data, and that's what Greenlight offered to you. That's quite modular and configurable as well. To adapt it to your own architecture, can be run as a web service or can be run on a local server. If you download the package, there is some user interface available, or you can just include the brick in your own data pipe. What's about the current status? So the first beta 1.0 has been released during summer in August this year. So right now in December, we are delivering this new revised beta, the 2.0, which includes some new features. And the goal, of course, is to continue the tests to get from the national access point some feedback and return on experience. And some further development are already on the way with common validation rules, because the tool, and Peter will explain it more in detail, is checking, of course, the consistency according to the XSD, but also and mainly is testing some operational rules, and we also expect to introduce this support for the third-party customization of rules. Potentially multilingual user interface could be also part of the coming extensions if this becomes a strong requirement from the community, let's say. But yes, that's just to introduce in quick word the validator, and I will now hand over to Peter, who will make a concrete demo of the tool.
Yes, hi. I will do a live demonstration of the tool, and first we do a brief overview of a happy case, just so you can see the tool and how it works. And it also has two interfaces, one web interface and one terminal interface. I will show you both. And then later in this session, I will go into more detail about the tool, the architecture, and how to customize it yourself. But first, we just demonstrate it. So the tool is using Docker as a platform to run the tool. And that's an easy way to package everything you need in one image or one container, so you don't have to do a lot of setup yourself and install lots of software packages. So we are using Docker as the platform. So you have to download and install Docker before you're trying the tool yourself. But it's easy. You go to docker.com and then you follow this getting started guide. And I have already done this on my computer here, so I will not show it because it takes some time. The next step is to download the image with the Greenlight tool, and that I will try to do online. So for that, I need to go to the terminal and give the command Docker, and that's the command line interface to Docker. And then say I want to pull an image from Docker Hub where we have published this tool. So just do that. And now it has downloaded the tool. If you haven't done it before, if it's the first time you do it, it takes some more time. It downloads a lot of packages. In this case, each image was already installed on my computer. So it just checked that it was okay, and it was quick. So now I have the tool installed on my machine. I have all the software, all the packages here. So the next step is to actually start the web interface. We want to start with the web interface. And that's another Docker command. And all this is documented on the GitHub page. So you get the documentation and instructions there. So for this, I just say that I want to start this server. So, and then we go to my web browser. And you can see this is the page, and it's served from my local computer.
The camera is there.
Yes, but I need to see what they see. So you can see it's served from my computer, and you, at the bottom here you can see the status of the server. It's so up and running and it's okay. You see the start page. So you can select to start validating. And this is a new version. If you have seen the tool before, we released a new version this last Friday, where we have a new concept with packages or profiles, where you can take a national profile or a standard profile of NeTEx and then combine it with some predefined rules. So you don't have to select each and every rule you want to use. You still can run the customization yourself and select rules, but in this case I show the new feature where you can select from a list of packages. So in this case I will select NeTEx Lite with all rules. Oops. And then when I have done that, I select the file I want to check. So if I want to check NeTEx file here, it's a smaller example. I open that file and it uploads, so you can see here in the status that it's uploaded to the tool, and then I can do the validation. So you see that it's running and doing the validation. And we actually found a bug in the new release, so it don't update the status of the progress. So when it's finished, it should say that it's finished and everything works okay, or if it's an error, but you have to refresh the page. So in this case, it says valid, the file is okay. And you can go down and see more detailed status. If there are any errors, we will see that later in the demonstration. You can actually see the error and the exact line in the XSD or in the XML file where there were. And if there's a lot of errors, you can actually download the report as an Excel file or CSV file as well. So that is the web interface. It's used for testing single files or a bunch of files more locally to verify file easily in your testing. The other way to use the tool is via the terminal. So you can access the tool via parameters and commands from the command line, and this is to be able to integrate the tool in your own pipelines or in the tool chains where you transfer data or receive data from a party, then check the file and then sends the result to another system. So you actually run it via Docker as well, and then you run the command validate. You say which profile you want to use, and also you can also set which rules you want to use in this validation. So in this case, I use a rule that's called every stop place has a name. So it goes through all stop places in the file and check it. And then I give the file to check. And this is a really small file just to have a quick demonstration, and it's validating fine. As we saw in the web interface, the XSD is validating okay, and now it also validates the rule. Okay, so and if you get any errors, you will get feedback here as well on what error it is and on which line the error occurs. And you also get the report file that you can download from the tool if you need to go into details. So that was a quick overview of how the tool work and what you can do with it.
Peter, actually, our recommendation is that for larger files and for, I mean, if you want really to run it for big, for many files, to use the Docker directly.
Yes,
or,
the web
to
interface is
yeah.
to use it's to make it easy to start using the tool and understand how it works. But if you are working with large files or large combination of files, then the command line interface is better.
Or scripting.
Or scripting, exactly.
Yeah.
You can use it script into your own tooling.
There's a question in the chat.
Yes. Well, this is something that we will talk about just afterwards.
Yes,
but you can.
But when we are setting up the rules and design the rules, we say also that this rule is an error or this is a warning. So, or it could also be an informational warning there. It's not severe at all. So it's defined on the rule level. I think I have said all this.
Very nice. So we can give the floor to Nick. So Nick, now you will enter more into the details of the validation rules that Peter just showed us very quickly through the packages. But yeah, the floor is the.
Thanks, Anastasia. So if we can move to the next slide. So first of all, let's just take a step back and think what we're trying to do here. Essentially what we're trying to do is to get a data set that from a database on one system, say system A on the left, into another system, system B, as correctly and safely as possible. And we've agreed a common format, NeTEx, into which we're hoping that the system A has managed to export both the data we need and in the correct format, and that is all up to date. And so we above all, we want to be in a position to know that before we start spending time computational resources importing a data set into our system, it's correct and there aren't stupid errors that are going to take us a long time to hunt down. So this is really to help both sides of the exchange to make sure that they're doing it right. And if we look at the next slide, we see that the where a validator comes in. So it's basically a tool you run to check your data before you import it. And because we're using XML, in fact, this is the main reason for using XML, we get a large number of built-in checks effectively when we describe a schema, and there are a lot of off-the-shelf automatic validators that can take the rules in the schema and check our data and tell us if we've got bad XML and feed it, give feedback to the exporter, both to correct his data or his export if necessary. But that's not quite the whole story, because if we look on the next slide, there are actually yet more rules that we can apply to beyond what you can do just in XML that can further help us make sure our data is good. And in particular, when we start getting to the higher level things we can test, because NeTEx is based on transmodel, which is a high level conceptual model, we've got lots of useful notions of things like space and time and what the model elements are that can be used to do additional checks. And I'm going to be talking about some of those rules in just a few minutes. But at the end of the day, this is all about improving feedback and improving data quality. Essentially, the Greenlight tool can be understood as having two aspects. First of all, this is running the normal XML validation so that you can get feedback that the XML has been checked. But then on top of that, it's running a set of custom rules that are handwritten, that have been based on the semantics of transmodel and on the conventions of that have been agreed in the profile, whether it's European profile, your own national profile, or some custom profile of our own, that are going to be applied to the XML to check that everything is okay. So let's go on to the next slide and just review the different types of rules we've got. So we've really got two main classes. We've got the rules that the schema will do for us, and we've got the additional rules that the custom validator program will do, some of which come from transmodel, some of which are just based on good practice and like organizing our way in our data in a good way, using the correct identifiers for our profile, and then you may even have your own very specific, more detailed checks that you want to apply. Across all the rules, you've really got notions of, well, how severe is the error? Is it something that I could maybe automatically repair, or just drop the offending element and the rest of the import will go ahead? Or is it so bad that it's going to blow things up? It's obviously more efficient if you can catch lots and lots of errors on a single pass and then go back and fix them all rather than having to run it fix one error at a time. So we have the notion of severity of the errors. So there'll be some things that are so bad that any computer is going to puke on your data and can't make sense of it. There are others that are really minor things that you can just sort of note. So let's just begin now, if we move on to the next slide, with summarizing the XML, the rules that we get for free in XML from the schema. So that's going to do a lot of the very boring low-level lifting, making sure that every comma and every start and end space and tag is there. The computers being stupid and essentially everything has to be exactly right for them to be able to process it. But it can also check the data types in quite sophisticated ways. So both the built-in data types like dates, but more sophisticated, you can have your own additional, more complicated data types added. And of particular interest, it can do integrity checks, like making sure that all the identifiers are unique, or that if you reference an element from another element, that you've defined the element that you're referencing in the document, if that's what the profile requires. So just to give you a flavor of that, if we look on the next slide, I've illustrated a chunk of XML that's defining a stop and some tariff zones, and you can see the sort of thing that it's checking. So first of all, all of the syntax at every last tag, the order of the tags, whether the tag's mandatory, the correct encoding of the XML is all checked. The data types, so those can include things like dates and dates and timestamps, but also more special types of numbers like longitude and latitude, enumerations. So we're getting a lot of very good validation, because a lot of the sort of common errors that are in any computer export tend to be these low-level boring things, and all those can be caught and fixed before going in and polluting the importing system, if you like. And as I said, we've got uniqueness, so that every identifier of a given type can be specified to be unique, and any reference to another identifier. So here I'm referencing a tariff zone. This will cause a check to be made that that tariff zone that I'm referencing has indeed been defined elsewhere in the document. So those are the sort of classic XML changes, validation rules we get for because we're using XML and we've got a schema. What what why do we need to go beyond that? Why do we need custom validators? In XML, you can only really express fairly straightforward sort of atomic checks. If you want to start doing complex cross checks that perhaps depend on the semantics of the data, like this must be earlier or later than that, or this must be adjacent or within the spatial coordinates of that element. You can't really express those in XML, but you can check those kinds of things very easily as a custom rule in a validator. You may also have conditional rules that apply in some cases. So, for example, if you've chosen to have a tariff structure that's point-to-point, then you should have all the point-to-point elements defined. But if it's not a point-to-point tariff, but rather a zonal tariff, then you should have all the zones defined. So you can have sort of cross dependencies between which sort of things you need to define to populate a model, and those things can be checked. You can also parameterize rules so that you could have different rules for different cases. I'll give you an example of that in just a minute. And you can also put in checks against external data sets. So maybe if you want to check not only that all your stop identifiers are unique, but they're defined in your national database before you import the data, well, then you could add in a check that checked a particular data item like a stop code or an operator code against a national data set. And then one other very useful thing you can do with a validator take several documents together and validate them as a set. So if you've got elements declared in one element that are in document that are referenced from another, you can basically check that everything fits together. Most off-the-shelf XML validators don't seem to be able to do that, even though it's not ruled out by the XML architecture. So essentially what we can do is have one validator that's effectively taking several files and validating them as a whole to check them. Whereas typically an XML validator is only going to work on one document at a time. So before I say a little bit more about some of the rules which we've implemented or are implementing in the Greenlight validator, I just want to say a little bit about how we arrived at them and what the process for deciding them is. We've basically built a spreadsheet of a large number of useful rules that we've identified. A lot of these are listed in the European profile in Chapter 11, so it gives out ideas for rules that could usefully be checked. So we've built a spreadsheet of these rules. We've assigned severity levels for them. We've decided which ones could be parameterized, and then we've kind of prioritize them to decide which ones to implement, starting off with the sort of both the most valuable ones, but also straightforward ones and ones which are computationally aren't extremely expensive. So one of the issues in deciding which rules you implement is you need to think a little bit about performance and scalability and so on. And you may also want to think about the order which you run them, because there's some rules it's not worth doing if other more basic rules haven't succeeded. So this list will be a work in progress. We could add to it to add further rules in the future, or you could pick up particular rules that you want to implement in your custom validation thing from that. And each of these rules is given a name and a priority so that you can relate it to what the script. If we move on to the next slide, this is giving some ideas for good, useful rules that we can take from the transmodel conceptual model. Because in the transmodel model, we've got a careful separation of notions of time and space, we can take advantage of that to apply rules. So I've already mentioned, so for example, we could check that start dates are before end dates, because that if we're making a journey, we'd expect the times on each stop along the journey to increase along the way. We can also check that sort of rules of space are obeyed, that stops are within a reasonable distance of each other, that the coordinates of a stop are within the coordinates of a town that the stop is allegedly placed within. We can look at the implied speeds of the passing times on the journey and see whether that's appropriate to the mode. We can look at whether the data is, the dates that are shown are present or coming up soon. So obviously, if we start seeing timetables for 1905, something's gone wrong unless we're encoding a historic timetable or something. We can also do various interesting consistency cross checks, like if it's a rail journey, it should be stopping at rail stations and not at buses, and the modes should correspond. And we can also check for that all the elements we'd like to see that go together are there, so that a service journey has a day type and an operator and passing times and so forth. To give you an example of some parameterized rules, if we go to the next one. So if we think about the, if we wanted to check that the stop distances between a stop are reasonable, well, that's actually going to depend on the mode of the stop, and it might even depend a bit on my network. If it's a long distance network, I might have very long distances between stops. If it's a local network, I might have shorter distances. So there's some rules that we might want to parameterize, so you can set your own sort of approximate values and get a warning, or if you see a value being exceeded. So if you, for example, if you see a bus stop that seems incredibly far apart, or if there are a very large number of stops shown on a route, you could have that flagged as a warning, as something that's suspicious to check. Then for the other type of rule, if we look at the next slide, that we can get the validator to implement, is things that are really specific to a profile. So these may not be generic for all NeTEx implementations, but for our particular profile, they might be relevant. So things like which identifier code spaces we want to use, which are the exact attributes we want to be present. Most attributes in the NeTEx schema are actually optional, because we didn't want to have hundreds of different schemas, each with a different set of mandatory or optional values. So we've made them mostly optional, and it's up to a profile to decide which elements they want to populate. We may also prefer, in your particular national profile or local profile, to organize the elements in a particular way. So place, say, elements in line, in context, rather than in a sort of flat way at the root, or you might want to do it the other way around. If you, by choosing one particular organization, you can generally make it easier for export tools and import tools to process a schema. So that might be why you want to do that. You could also make sure that the metadata that you need for your workflow processes, like you might want to know which version of the schema, which version of the profile, how current the data is when it was last refreshed. All those sorts of things can be checked, because there's appropriate slots in the schema to record that. And you could check as I said before, your references against external databases to make sure that any key reference data values are all correct. So just and then just summing up on the next slide, these are the rules that we have currently. So that's so in the alpha version of the first beta of Greenlight, there were about 8 rules implemented, doing some of the most common things. And that's now gradually being extended, and also the system is open, so you can extend it yourself, which I think is what Peter's now going to tell you about.
It is Stefan, actually.
Oh, sorry,
That's
Stefan.
fine
Sorry,
for me
Stefan.
too.
No, Stefan. That's right. Stefan's going to give you some examples of running these rules on real-life data sets. So,
Yeah.
yeah.
Okay, so
Stefan.
so the outline basically is in the past we have been fed different types of data. For example, so the data could be converted to other formats such as GTFS or maybe national specific profiles like Dino or VDV formats, or maybe even intermediate formats that you can use in a journey planner that expect some kind of data quality, that you would use the same identifier like you would do the same departure time in your timetable. It would not make sense that you go from one format to the other format and change information. So it expects that the format has some kind of quality. And maybe let's look at the first slide of a kind of quality that you would see in the national access points. Small letters, but I will explain you what happens here. So one of the most bad problems that you can have in your NeTEx files is that your identifiers, so the ID attributes in the objects, are duplicated. And our DATA4PT validator, and basically by the XSD that is being used, can show us that all the lines, let's say basically on the lower part of your screen, states that the element stop place has a duplicate key sequence for the stop place 0_CDT and then with a version number. And it seems to be that in the Luxembourg national access points, all the stop places have the same ID. That makes no sense, and it also shows that probably their entire stop registry is useless for us, because we can obviously show them and renumber the identifiers of those things, but you can never have the right references to those IDs. So your passenger stop assignment would absolutely not make sense. Some other interesting things, likely because the IDs are the same, other errors occur now. The scheduled stop points, so the stops that you would see in your timetable, are too far apart, likely because all the stop places are now treated as a single stop place, and they don't make any sense regarding the distance. What this shows is that what has been exported has never been checked, not by a validator, not by hand, and you can wonder, if you have a delegated regulation and you must publish something, isn't it, let's say, a waste of your time not to actually check the data quality? And this is let's say the primary data quality that you should check for. Are my identifiers at least unique? There are some other, let's say, tiny stupid errors like the language not being correct, and in this case it's German, but it's not written in the correct ISO code, and some other things are let's say missing from the file. But I think this is showing what the end customer of open data in Europe gets presented when they go to a national access point, because this is not a single example. Let's go to the next slide. So when I first saw the Austrian NeTEx files for validation, I noticed quite some interesting situations regarding to positioning. So as you might know, that latitude and longitude in the days of Google are always reversed, and you never know which comes first, but the X is the longitude and the Y is the latitude. So typically you would say longitude and latitude, but because of Google Maps, this all was mixed around. Now look at the service link, and likely this is something that no validator will ever tell you unless it's really smart. The line string in the first position, which is a coordinate, has a coordinate of 14 by 47. The second coordinate is 47 by 14. You already noticed this, either of them cannot be right. Either the first one is right or the second one is right, but it cannot all be right. And these kinds of issues appear a lot in the NeTEx export. So this is a very, you can directly see that this is an issue, but typically if you would see it for a scheduled stop point or a stop place, you would never know which of the coordinates are correct. Yes, you could do heuristics. You know, for example, this is in Austria, Austrian data set, so the coordinates must be in Austria, but try to figure out a kind of validation rule that works for entire, let's say, for all of Europe, or something like where you might be able to switch the coordinates. For example, England. Yeah, that's outside of the EU, but never know. Don't let us distract from, let's say, the presentation. So the checks for latitude and longitude are very important, but it seems to be that those kind of things are implementation details. So once you make the error once, you're likely not ever to make the error again. Otherwise, you will be laughed at. Let's go to the next slide. What I also noticed from this export is that the use of version any, which is completely allowed by the NeTEx specification, is often used. Why I think this, let's say why I think this is a problem is because if you in your entire file have the use of the correct attribute with version, so for example, version with a date, and you start to use version any in some part of the file, that requires that your references also refer to the correct version any, otherwise your XSD controls will never work. I would suggest avoid using version any unless you know correctly how it works, or what the IDs behind version any were. Next slide, please. What I also noticed is that in the Dutch exports, some operators, I think 3 of them, started to reference the wrong object type. So we are looking at here at a timing link, and a timing link is something in the Netherlands data exchange where you go from one stop to the other. So for example, a stop point, and between them you eventually want to assign the duration, how long the bus would take to go from A to B. As you can see here, this operator, in this case the city of Amsterdam, started to use not timing points or scheduled stop points, which are actually the same kind of category, but instead route points. This is a problem because route points cannot be, according to the XSD, assigned to the timing link. While it might make sense that the timing link goes from a route point to the other route point, this is not correct. So this is something that you would see from the validation perspective. This does not match the XSD. Let's go to the next slide. What we also saw in the EPIP profile, in the operating period is referencing here to UIC operating period. If you would make an implementation, that would mean that you need to aggregate all the variants of the operating period to some kind of index. And that basically means that from the lowest kind of object, you have a very large index where all the identifiers of all objects would be in. And from the higher level objects, you would have more specific indexes to look up the IDs in. You can fix this for an implementation very elegantly if you would go to the next slide. If you would add name of ref class UIC operating period, then the implementator can directly look up in the right can look up directly the index where the identity is from. So in this case, it would look in the UIC operating period index for the correct reference. These are kind of subtitle hints that are very easy for a producer to do, but this would directly improve the performance of anybody using this information. So I would suggest just add them at least to, let's say, get happy customers. Next slide, please. What we also saw is that some, Nick just mentions that some profiles have XML schemas, and that means that the that somebody for this profile created an XML schema that defines which are the mandatory elements, which elements should you use, which elements should you not use. And it typically is a smaller profile than the big NeTEx file. The big NeTEx file could be seen as a vocabulary, while the smaller would be something like a grammar dictionary. When we published my Flixbox XML to Mens, which is a German company that handles in timetables, they mentioned your file is completely correct according to the NeTEx XSD, but it's missing something. It's missing service calendars. You won't see this currently in the DATA4PT validator, but when we take a look at the IPIP XSD created by Ulf, then you can directly see that something is not expected, and the something in this case was the date types, and we would have expected a service calendar where the date type should be placed under. These kinds of investigations show that while you can do something completely correctly according to the XSD, it's still invalid for a specific profile, and thereby a consumer cannot read the information. Still, our validator can add this kind of rule, and it still shows that there are some improvements that can be made. But structures, let's say issues like these, typically requires a lot of manual search. Next slide, please. So what I would suggest as let's say somebody that has seen a lot of export from NeTEx, after exporting, if you're the producer, just use the DATA4PT validator. It includes all the XSD schema validations that are present, has extra validation rules like timing rules. But if you want to dive a little bit deeper, take the libxml tool, which the DATA4PT validator also uses, and take out the following comment. No out means don't export the entire file to your screen. The schema means the schema that is part of the NeTEx publication, and your file .xml.gzip or just .xml basically gets a complete validation on your screen, and you do it on the lowest level possible. If you can't do that, just take the DATA4PT validator. It will do it for you. It has a much nicer output, but at least you know how to do it yourself. If you want to go one step further and you have your own profile, try to define a smaller profile, as profile for your own country. So EPIP is already done. The Dutch profile is already done. Maybe a VouDeVou or a Nordic profile would sincerely help people to export and import this information. This XSD probably has a lot of minoccurs stating 1 or above, and therefore having all the mandatory elements in it. Sometimes, and this is what I do at night, I just read the XML files by hand, or at least manually, and you will just see strange things, let's say tags as to be done, or I will do it later, and specific quotes that directly show somebody sent some file but never review the file themselves. It's something like eat your own dog food. If you would like to use the information within your company, try to export the information, import it in your own system. If that works, that's fine. Importing in your own system is interesting because many vendors at this moment can export EPIP but cannot import it. So you would never know if your file actually works. Next slide, please. So then we go to Petter, and good luck.
That this tool can validate XSD files, and we have seen example of that, and then that is customizable, that you can add validation of your own. You can actually upload your own profile XSD, as Stefan mentioned, as well. If you construct your own profile, you can add it to the tool and use the tool for validation of that as well. And you can do that because the tool is built in modules, and this is an overview of the architecture of the tool. So we have this validation engine in the middle that connects everything together and have some logic. But then the validation engine is using libxml, that is an open source standard library for XML. And Stefan also mentioned another way to use that tooling. And then the validation engine uses NeTEx XSDs or profile, and it could be the standard XSD or a standard profile, or it could be the EPIP or some national profile. It's configurable in the settings. And you use, as I showed you earlier, you have this command line interface where you give parameters to the validation engine, and you do that via the configuration API. So the web interface that I showed you, it's using the same configuration API as the command line interface are using. So that's how you access the tool and how you can tell it to do different things. You do it via the configuration. And then you can adapt the tool with your own rules. And we have provided a set of standard rules. And as Nick showed you, we have a list of rules that we are working through and that we think are valuable. And the scripts or the rules are also examples of how you can develop the rules. So we have found different types of rules that checks for different types of data in the files. So you can use the existing scripts as example of your own work. And the scripts are using an API also against the validation engine to get access to functionality and the data that the validation engine provides. So if you want to build your own and customize Greenlight, what can you do? You can do and add your own profiles, as I said, but you can also add your own rules, and we encourage you to do that because we can't provide you with all the rules that exist for your specific needs. So you can download the tooling and the source code from GitHub and start working from that and use our scripts as an example. And I'm going to show you how to do this, and I try to do it as simple as possible. So this is a really simple example. But the first thing you need to do, it's actually to understand what you are checking and what you are looking for in the XML file. So you have to know which element you want to check and how they relate to other elements. So that's the first thing. And then you can find a template script from our library that does something similar to what you want to do. And then you can go in and edit the script and add your own validation. And at last, you test the script, of course, but you should test it on a file that validates okay, but you should also test it on a file that validates with an error. So we will try to do this live. So I have a file and see if we can zoom in a bit. So this is the example file I used before, and it's a really small one. But I know we want to check the length of the name of the stop place. That's the new rule that we want to build. And then I know that the stop places are in the site frame. So I can go here and look up and I see I have stop places. And in this file I have 2, and that's not large at all. And then I can see the name here is the tag in this element. So this is what we want to check, and we want to check the length of this. So we can see this is 22 characters long. So if we say in this case, you have to decide that or use a parameter as Nick showed you. We say we want to check the length of 25 characters. So then I go to the source directory, and this is the tool, and you can see if I can make it a bit larger. So here is some of the scripts that the file or the tool is using. And as you can see, I have a script that's checking for that the name exists. So it sounds like similar to what we are trying to do. So I can use that script as a template. So I copy it, and then I can go into the script here. I need to change the name as well. So I go here and I change the name of the file. So, and the naming is not very important, but it's good to have a name that tells what the rule is actually doing. So now I have a new script with a new name, and I will actually copy this one. So I'm changing the script that was there that checked for a name to a new script that will check for the length of the name. So if we look at this, it actually has a double comment here. So first, the scripts are written in JavaScript, and it's to make it simple for more people to access them. The main validator tool is written in Go. And then first you define some imports that libraries that you want to use from other parts in JavaScript or in our validator engine. And you also set the name of the script. It's used by the web interface, for example, to actually show the name. And then we are using something called XPath to go through and work with a XML file. And in this case, we are working with a path, so you can see where the data is located in that file. I will not go into detail of how this works, but we can ask afterwards. And we are looking for the name in this case. So then I have defined something so the script prerequisites for the script, and then we come to the main function. And here this function is getting called by the validation engine when it's going to run the script on the file. And it adds a parameter it's a context. And in the context, you can access the data. So the main validator engine reads the files that you want to check. It could be one or more files and packages in this context that the script then can access. And the script can also access some helper methods from libxml that helps you to search in the XML file and find what you're looking for. So in this case, we are finding all the stop places, and we have a method to iterating over them, so we can actually get each and every stop place node in the file. So first I check that the node has an ID, so we can report the ID number. And if it doesn't have an ID, it reports that as an error. And then we can go to get the name. So we pick out the name that we saw in the XML file earlier. And we check that the name has a length that is about 25 characters. It should probably be smaller than, or I don't change it. It's too long, so it changes. It looks if it's more than 25 characters. And if the name is too long, then it adds that to the error list. So it works through all the stop places and adds to the error list, so it doesn't stop at the first one. So when it has iterated over all stop places, it sends back the list of errors from this script back to the validation engine, and the validation engine collects the results from all the validator scripts and reports back in the web interface or to the terminal, and also writes it to the result file. So if we try to run this, and earlier when I showed you how to use this, I used example data and then the built-in script. Now I have a new script that isn't in the tool from the beginning. So I have to use a more complex line to start this, where I can map a directory on my computer to the virtual machine that is running inside Docker, so I can access files on this machine's local hard drive inside the virtual machine that the tool is using. And I will not explain this, but if you understand Docker, then you know what's going on, and otherwise I can help you afterwards. It's an error in my script. Actually, I think we do it like this. Sorry, I think I did a double.
Live but yeah, something is it was read already. Thank you actually for stay with us. We are a bit we have exceeded the 1 hour, but I think it's quite interesting to see the results.
So now it worked. I had
Yeah.
made an error when I copied the source code. So now it has used this new rule, and this file was okay because the name wasn't too long. If we try to go back and actually change the name of the stop place, and then we can see that the rule is triggering,
Yeah.
and it says that it doesn't validate, and you also get the line number the error is at. So a very quick overview of how you can customize the tool, but you get the idea, I hope, and you can ask questions afterwards.
Exactly. Thank you very much, Peter. Thank you very much, all the facilitators. Actually, as you have seen, we have touched many different aspects of the tool. So what is the strategic point of view? What is the background work? What is the ongoing work? How to customize? What errors you should check for, what is our recommendation, how to use the tool, and also in general how to validate your data. So many things they have been presented. Since we don't have much time, but I don't see any additional question on the chat, I will like to thank you for joining. We are promising that this material will be again online in ITxPT YouTube channel, and it will be posted on the webpage and also in LinkedIn. So you will be notified for that since you have been registered and participated to the webinar. So we invite you to follow up with this. You can reach us directly from the technical request form, which is also available on the website. So please, what is the correct channel for support? So we have the GitHub. If you want to declare to report an error on the validator itself, and you want to ask how to use the validator, for example, questions regarding customization can be reported directly to the GitHub space. And then you can also reach us out through the Data4PT website. There is this technical support tab where you can actually make a more generic question without any particular form. You can add many questions in one form. So you can use both channels. The GitHub is more, let's say, oriented to technical issues. So thank you very much for joining again. Thank you, the facilitators, again for your support. And see you soon in our next webinar.
Thank you.
Bye-bye.
Thank you.
Bye.
Bye.
Bye-bye.